Alrighty, folks, welcome to class. We are going to start with our bell ringer, just like we do every day. So make sure your blue sheets are out and take about 2 minutes, pause this video, and work on the bell ringer. Awesome. Now that you've finished your bell ringer, we are going to go over the answers together. So you need to give each inequality in interval notation. So our first one is x is greater than or equal to -2. So it can be bigger than -2, but it can't be smaller than -2. So our answer should be -2 on the left, positive infinity on the right, with a parentheses around positive infinity and a bracket around -2. For our second one, x is less than or equal to -3. We still have an equal sign underneath that inequality. So -3 is going to have a bracket around it. And the smallest it can get is -infinity, which will have a parentheses around it. And our very last one, we're going to need to solve first. So I need to add 7 to both sides, and I will get x is less than or equal to 11. When I'm graphing, or when I'm writing this one in interval notation, the smallest it can get is -infinity. The biggest it can get is 11. And we have a line underneath our inequality showing that it's equal to, so we have a bracket holding onto that 11. So give your partner an X if they got it wrong, give them a circle if they got it right, and trade your blue sheets back. You can take out your notes for the day. If you did not get notes on Friday, the notes are on the front table. So the substitute can pass those out if you did not receive notes on Friday. Take a second and take those out. We're going to talk about solving multi-step inequalities. So we solved one-step inequalities a little bit on Friday. We solved equations very similar to the same way we solved them with a normal equal sign. But now we're going to have multiple steps to solve these equations. So we're going to start off by reviewing how we solve regular equations. So both of our first two examples are normal equations that we're going to solve. And I'm going to do number 1 with you, and then you're going to take a second and do number 2 on your own. So when I'm looking at number 1, this is a complex equation. I'm going to solve for x. So the first thing I'm going to do is I see I need to distribute. So I'm going to distribute that -2. And when I do that, I get -6x minus 10, still set equal to 4x plus 20. I'm going to add 6x to both sides to get 10x plus 20 equals -10. And then I'm going to subtract 20 from both sides. And I get 10x equals -30. To get x completely by itself, I'm going to divide both sides by 10. And x will equal -3. I want you to try solving number 2 on your own. So number 2, we're going to have to distribute twice. So make sure you distribute first and then combine like terms. So take a second, pause this video for about 1.5 minutes and solve number 2. Awesome. Now that you're done with number 2, we're going to go over the answers. So we should distribute first. So when I distribute both of those, I'm going to get -7p plus a -49 plus 3p plus a -12 is still all equal to negative 17. Now I'm going to combine like terms. So I'm going to combine negative 7p and 3p. That becomes negative 4p. And then I'm going to combine negative 49 and negative 12. That becomes negative 61. From here, I'm going to add 61 to both sides. And I get negative 4p equals 44. When I divide both sides by negative 4, I get p equals negative 11. And that is my answer. So we're going to be using those same processes when we're solving equations with inequalities. We're going to quick review what each inequality means. And we have one special thing to remember when we're solving inequalities. So first off, our first symbol is our less than symbol. And that means that our left side is smaller than our right side. Our second symbol is our greater than symbol. Which means that our left side is bigger than our right side. Our third symbol is less than or equal to. And we know that that means our left is bigger or the same as our right. And our final one is greater than or equal to. Which means our left side is bigger or the same as our right side. Sorry, I think I wrote bigger for our less than. If you caught that, good for you guys. This should be smaller. And our special thing that we need to remember, this is very important to remember. I don't care what you do, circle it, star it, give it a bunch of hearts, but we need to remember that when we multiply or divide by a negative number, we need to flip the sign. So if I had negative 4x is greater than 2, when I divide by that negative 4, I need to flip the inequality sign. It's going to flip the other way. Instead of being greater than, it becomes less than, because I divided by a negative number. It's the same when multiplying by a negative number. So we need to remember that. It's very important. So let's start with trying a few. If we look at number 3, we need to first solve this. Then we're going to graph it on a number line right here. And then we're going to write it in interval notation. So we're going to need to remember the stuff we did on Friday for graphing and interval notation. So let's start by solving this. The first thing I need to do is distribute. So I'll get negative 20w plus 32 is greater than 52. I'm going to subtract 32 to the other side, and I'll get negative 20w is greater than 20. And when I divide by negative 20, keyword divide by negative, I'm going to wind up flipping this sign. I'm going to divide both sides by negative 20. When I divide by the negative, I flip my sign, and I'll get W is less than -1. So to graph this, since it is less than, I'm going to have an open circle around -1, and I'm going to be going in the negative direction. So draw in that negative line with an arrow. To write this in interval notation, I know the smallest I'm going to get is -infinity, and the biggest I'm going to get is -1. So let's try another one. If we look at number 4, I'm going to solve for k. So I'm going to subtract 13 to both sides, and I'll get -4k is less than or equal to 14. When I divide both sides by -4, -4, I'm going to wind up flipping the sign, and I'll get k is greater than or equal to -3.5. To graph this, I'm going to show that we're in between -4 and -3. It's greater than or equal to, so that means I'm shading in my dot, and we're going in the positive direction, because we can be bigger than -3.5. And then in interval notation, the smallest I can be is -3.5, and the biggest I can be is infinity. Remember, with infinity, we always have a parentheses, never a bracket. So once you have that written down, you can flip your page over. We're going to take a look at a few more examples, and I'm going to have you try number 5 on your own. So take a second, pause this video for about a minute, and try number 5 on your own, graphing it and getting the interval notation after you solve. Awesome. Now that you have finished solving it, we're going to go over that answer together. So I'm going to combine like terms. So I'm going to move 4x to the other side. When I subtract 4x to the other side, I should get 5x. And then I'm also going to subtract 5 over to the side with 15, so that I can get those like terms together. And I'm going to have 5x is less than 10. When I divide both sides by 5, I get x is less than 2. I did not need to flip my sign this time because I divided by a positive number, not a negative number. So to graph this, I'm going to put a point at 2. I should have an open circle, and I should be going in the negative direction. Our interval notation should be -infinity to +2, both with parentheses around them. Now, we're going to go over 6 together, and then we'll move on to some word problems. So in 6, to solve for b, first I'm going to subtract 5 from both sides. I cannot multiply by -3 first because I have the +5 after b divided by 3. I have to move any addition and subtraction first. So when I do that, I'll get b over -3 is less than 5. And now to get b by itself, I'm going to multiply by a -3 on both sides. I'm multiplying by a negative, so my sign is going to flip. And I'll have b is greater than -15. So on my number line, I'll put a point at -15. It will be an open circle, and we're moving in the positive direction because it's going to be bigger than -15. And that in interval notation is -15, +infinity. Looks like we have that slide twice. Let's take a look at number 7, our first word problem. I'm going to do number 7 with you, and then I'm going to have you try to do number 8 on your own. Number 7 says an amusement park charges $15 for admission and $2.50 for each ride. You go to the park with $60, write and solve an inequality that represents the possible number of rides you can go. So we know that it's going to cost $15 plus $2.50 per ride. We have $60, and so you can't spend more than what you have. So everything on this side needs to be less than or equal to $60. So our symbol is less than or equal to. Now we're going to go through and solve. I'm going to subtract 15 from both sides, and I'll get 2.5x is less than or equal to 45. And then when I divide both sides by 2.5, I get x is less than or equal to 18. And that is my solution. I'm going to have you guys try number 8 on your own. So take a second, pause this video, and try 8. Awesome. Now that you've finished 8, let's take a look at it. So we have $18.50 to spend. Initially, it costs $14 for pizza and 75 cents for each additional topping. $14 plus 75 cents per topping. We can't spend more than $18.50. So this side needs to be less than or equal to $18.50. I'm going to subtract 14 from both sides, and I'll get 75 cents times x is less than or equal to 4.5. And then when I divide both sides by 0.75, I get x is less than or equal to 6. So that's the amount of toppings I can get. 6 toppings. We have one more to go through, and then you can get started on your homework. Number 9 says, for Park College's basketball games, it costs $15 to attend. A season pass costs $170. At most, how many games could you attend at the $15 price before spending more than the cost of a season pass? So $15 per game, we want that to be less than or equal to 170. Because we don't want to spend more than the season pass if we're not going to buy a season pass. So when we solve this inequality, I'm going to divide by 15 on both sides. I get x is less than or equal to 11.3. So I could go to 11.3 games. But I can't go to 0.3 of a game. So I can go to 11 games before I should buy a season pass. All right, that is all we have for notes today. You may take out your computers and start on your My Open Math assignment.